In section R.4, we look at polynomials. And again, just as a reminder, this is intended to be a review. So a polynomial in one variable is an algebraic expression of the form an multiplied by x to the n plus an minus 1 multiplied by x to the n minus 1 plus etc. And the thing to note here is that whatever the number n is, each successive term of the polynomial has a power of x that is one less than the one that preceded it. The an and an minus 1, etc., those are simply the coefficients of the polynomial. So as an example, let's look at the following. These are all polynomials in one variable. The first one, we have 2x plus 7. So remember, the power here on the x is 1. So it's 2x to the 1 plus 7. So if you want, this would be a1, and this would be a0. In the next one, we have 3y squared plus 8y minus 3 over 2. This polynomial is in the variable y. This coefficient here in front of y squared would be a2. The coefficient in front of y would be a1. And the constant term, the number that is not attached to any variable, is a0. And by the way, a0 is usually pronounced as a naught. For the next one, we have 10x to the 7th power plus x times the square root of 5. And I know this looks a little bit strange, but square root of 5 is nothing more than the coefficient of x to the first power, right? So you can think of that as 10x to the 7 plus the square root of 5 times x to the 1. And you'll also notice that there are a lot of powers of x that are missing, right? So we don't have the 6th, 5th, 4th, 3rd, or 2nd power of x. And also the constant term on the end is missing. In the case where you have missing terms, the coefficients for those terms are simply 0. And the last one, the number 5 is actually a polynomial technically. So we don't have any power of x, all we have is the constant term. So it would be like we're missing all of these terms here, but we have the constant term on the end. Let's talk about polynomial terminology. So the degree of a polynomial is n, the highest power to which a variable is raised. The parts of the polynomial separated by plus signs or minus signs are called the terms. The numbers an minus 1, etc. are called the coefficients, and the leading coefficient is an. So the leading coefficient is the number in front of the highest degree term. The constant term is a naught, and normally we write polynomials in descending order. And what that means is, as we move from left to right, we go from the highest power of x down to the lowest power of x. So as an example here, we want to write the following polynomial in descending order, find its degree, its terms, its coefficients, and the constant term. So first, let's write it in descending order. Notice that the highest power of x is x to the 5th power. So that term should come first. So we'll write 3x to the 5th power. The next highest power of x is the term negative 4x squared, and then negative 2x, and finally the constant term should be last. So we've written it in descending order. Now let's go ahead and find its degree. So its degree, again, this is just the highest power of x, so this is a degree 5 polynomial. Its terms are simply the things that are separated by the plus and minus signs. But the thing to remember is that you have to include the sign when you talk about the terms. So the terms of this polynomial are 3x to the fifth, comma, negative 4x squared, comma, negative 2x, comma, negative 7. The coefficients are the numbers in front of the variables. And so you'll see we have a coefficient here of 3, a coefficient here of negative 4, coefficient here of negative 2, and then negative 7 is not called a coefficient. We call that the constant term. So when you talk about the coefficients, you can do this in one of two ways. We can simply list the coefficients, as I just mentioned, and then I'll include the constant term on the end here. Or you can be more specific about it. We could say the coefficient of the fifth degree term is 3. So notice the notation is A5 is equal to 3. The coefficient of the fourth degree term, well, there is no fourth degree term, so the coefficient would be 0. The coefficient of the third degree term would also be 0 for the same reason. The coefficient of the second degree term is negative 4. The coefficient of the first degree term is negative 2. And finally, the constant term A0 is equal to negative 7. Next, let's talk about some special names for some special types of polynomials. If a polynomial only has one term, such as 2y cubed, this is called a monomial. A polynomial with two terms, such as the one you see here, is called a binomial. And if a polynomial has three terms, like this one, we call that a trinomial. So we will very often find ourselves referring to monomials, binomials, and trinomials. If a polynomial has four or more terms, we don't have a special name for it. We would just simply say that we have a 4-term polynomial or a 5-term polynomial, etc. Let's talk about adding and subtracting polynomials. To add and subtract polynomials, it's a pretty simple process. All you need to do is add or subtract the like terms. So in this one here, you see that we have a third-degree polynomial added to another third-degree polynomial. So all we're going to do is just kind of group the like terms together. So we have 3x cubed here plus x cubed in the second polynomial. Then we have positive 2x squared and then negative x squared and negative 5x and positive 5x and then positive 7 and negative 2. So we're simply grouping the like terms together, and then we'll just combine the like terms. So 3x cubed plus 1x cubed, this is 4x cubed. 2x squared minus 1x squared is positive 1x squared, and when you have 1x squared, you don't need to write the 1 in front of the x squared. Negative 5x and positive 5x completely cancel. And finally, positive 7 and negative 2 is positive 5. So this is the solution to the first example here. For the next example, it's basically the same thing, except that when you are subtracting, you have to distribute the negative. So we need to make sure we distribute this negative to each one of those terms. So when we do that, we get s to the fourth plus 3/4 s squared. Then we have minus s to the fourth. And finally, the negative here and the negative here makes a positive s squared. Now, when we group the like terms together, you don't actually have to write them next to each other. We can simply identify that we have 1s to the fourth here, and we have negative 1s to the fourth there. So those are actually just going to cancel each other out. And then what we end up with is 3/4 s squared plus 1 s squared. And to do this, we just need to add the numbers 3/4 plus 1. And that, of course, is 3/4 plus 4/4, which is 7/4. So this becomes 7/4 s squared. So when you subtract, you need to make sure that you remember to distribute the negative sign, which is what I did up here. Now let's do some multiplication examples. Multiplying monomials is a pretty simple process. When you're multiplying two monomials together, we are simply going to multiply the coefficients together. So -2 times +4 is -8. And then for the other part, x squared times x to the 7th, what you do there is you simply remember your properties of exponents. So we're going to add the exponents, and that will give us -8x to the 9th power. Multiplying binomials together, to do this, we are simply going to make sure that we multiply the first polynomial by each of these. So we are literally going to take this first polynomial and distribute it to each of those. So when we do that, we get 3x plus 2 multiplied by -2x plus, and then we have 3x plus 2 multiplied by -3. And after that, we make sure we distribute on each one of these. So we end up getting 3x multiplied by -2x, which is -6x squared. +2 times -2x is -4x. And then in the second group, we have 3x multiplied by -3, that's -9x. And finally, +2 times -3 is -6. And then we just need to make sure we combine like terms. So in the end here, we have -6x squared minus 13x minus 6. Now there is another method for multiplying binomials, and this method is called the FOIL method, and I'm sure all of you have heard of that before. Let's just outline what this is talking about. So in this example, we have -7x plus 4 times 5x minus 1. And what we're going to do is make sure we multiply every term of the first polynomial to every term of the second polynomial. So the first thing I'm going to do is multiply -7x times +5x. And what I'm doing there is I'm multiplying the first terms of each of those polynomials together. After that, I'm going to multiply -7x times -1. Those are the outside terms, right? Because when you look at this, those terms are on the outside. Then we multiply +4 times +5x, and this is called multiplying the inside terms, because when you look at this whole thing, these are on the inside. And finally, we multiply +4 times -1, and those are the last terms. So you can see where FOIL comes from: first, outside, inside, and last. So now when we actually do the multiplication, -7x times +5x is -35x squared. -7x times -1 is +7x. +4 times 5x is +20x. And +4 times -1 is -4. And once again, in the end, we want to make sure we combine like terms. And in this case, we end up with -35x squared plus 27x minus 4. Now this next example is pretty much just like the last one, except that we don't call it the FOIL procedure. So it's a little bit more complicated. We have the polynomial 4y cubed minus 3y plus 1 multiplied by y minus 2. So what you want to do in this case is start by picking the first term of the first polynomial. And we're going to multiply that to each of the terms in the second polynomial. And then we do the same thing with the second term of the first polynomial. We're going to multiply that to each of the terms here. And finally, we take the last term of the first polynomial and we multiply it by each of the terms there. So you can see that I've drawn 6 arrows. We need to multiply 4y cubed times y, and that is going to give us 4y to the 4th power. Then we need to multiply 4y cubed times -2. That gives us -8y cubed. Moving to the second term, -3y multiplied by y is -3y squared. And then we have -3y times -2 is positive 6y. And now moving to the last term, positive 1 times y is positive 1y. And finally, positive 1 times -2 is -2. And now we just need to make sure that we group all the like terms together and combine those like terms. Now, the only like terms we actually have, if you look at it, are these two right here. And that's because everything else has a different power of x, or power of y, excuse me, right? These are all different, so we cannot combine these together. So in the end here, we're going to have 4y to the 4th minus 8y cubed minus 3y squared plus 7y minus 2. In the last part of this section, we're going to look at special products of binomials. The first one is the square of a sum. So we have the sum a plus b, and we're squaring the whole thing. And when you do that, you get this. Now, you don't have to memorize this formula. This formula simply comes from the fact that a plus b squared means a plus b multiplied by a plus b. And when you do the FOIL process, you end up getting a times a is a squared, a times b is ab, a times b again is ab, and b times b is b squared. And then you can see 1ab plus 1ab is 2ab. So that's where this formula comes from. The square of the difference is basically the same thing. The only difference is you have a minus sign in both of these places. So both of these will be negative, which is why you end up with a negative in the middle. But of course, negative b times negative b is still positive b squared. And then the last one is the difference of two squares. And they call this the product of a sum and a difference. So basically what you have here is a plus b multiplied by a minus b. So what happens here is when you multiply this out, you get a squared, and then we get minus ab. Multiplying here, we get plus ab, and multiplying here, we get minus b squared. And so these end up canceling out, and we get a squared minus b squared, which is what you see here. So if you want to memorize these formulas, you certainly can. There's no problem with that. But there really is no need to memorize these formulas in order to be able to perform these special products. So let's go through these examples. So in the first problem here, we have 3y plus 4 to the second power. So I'm going to write this as 3y plus 4 multiplied by 3y plus 4. And I don't see any point in memorizing the formula here, so I'm just going to multiply this out like normal. 3y times 3y is 9y squared. 3y times positive 4 is positive 12y. And then 4 times 3y is positive 12y again. And then 4 times 4 is positive 16. So what you should notice is that you have 12y plus 12y. So you have two 12y's. And two 12y's, of course, is 24y. So that's where the 2 comes from in that formula, right? You're always going to have two of the same thing, okay? But again, we don't have to know that to do this. All we have to do is simply add 12 and 12 to get 24. So we end up with 9y squared plus 24y plus 16. Now for the next example, it's the same thing, except now we have 4x squared minus 5 quantity squared. So this is going to be 4x squared minus 5 times 4x squared minus 5. And I do the same thing. Multiply this out. You don't have to draw these lines if you don't need to. 4x squared times 4x squared is 16x to the 2 plus 2 is 4. 4x squared times negative 5 is negative 20x squared. Negative 5 times 4x squared again is negative 20x squared. And finally, negative 5 times negative 5 is positive 25. Combining like terms in the middle, we end up getting 16x to the fourth minus 40x squared plus 25. And for our final example here, we have 7y plus 3 multiplied by 7y minus 3. And again, we don't have to necessarily know any special products or anything like that. We can just multiply this out. 7y times 7y is 49y squared. 7y times negative 3 is negative 21y. Positive 3 times 7y is positive 21y. And positive 3 times negative 3 is negative 9. And of course, the difference here from the last two examples is that these are going to cancel out, leaving us with 49y squared minus 9.